Consider the angle between two vectors. When two vectors point in the same direction, the angle between them is 0 because there is no distance between the vectors. If one vector is rotated, the angle between the two vectors will increase until the vector is turned around. Once the vector is reversed, the angle between the two vectors is pi, because that's the distance along a unit circle between the two vectors. However, as the vector keeps rotating, the angle no longer increases. The angle will go through the same values until it reaches 0 again, as the vector realigns with the original position. Something has changed about its angle though. At first the vector was rotated counterclockwise from the original vector, but then after it turned around, it was clockwise. The direction from the original vector changed when the vector got turned around, and so the direction of the angle changed too. A negative sign can be used to distinguish the two directions. So all of the angles which are counterclockwise will be positive, while the clockwise angles will be negative. Consider the points on the unit circle corresponding to the two angles theta and negative theta. From understanding that positive and negative angles correspond to different directions of rotation, these points can be drawn on the unit circle. By breaking up these points into their x and y components, a few important identities of sine and cosine can be remembered. First, cosine of theta is equal to cosine of negative theta, because their components line up perfectly. Second, sine of theta is equal to negative sine of negative theta, because while their lengths are the same, they travel in opposite directions. As functions, this can be expressed as cosine is an even function, while sine is an odd function. Usually, when studying trigonometry, the principal domain of sine and cosine are given as 0 to 2 pi. However, by shifting the perspective from 0 to 2 pi to negative pi to pi, the even and odd identities can be easily remembered. Moreover, by thinking of angles primarily being between negative pi and pi, an idea of rotation based on vectors can be imagined, rather than the standard angles between 0 to 2 pi, which focus on rotations as a cycle.